This is the third and final video in preparing for the final exam for PA Core 8. So let's begin. There are 10 questions as there have been in the past. You should have this document open in front of you, and my notes are already partially completed. You can follow along and add as you go. I'll be working in purple, so it'll stand out compared to the blue notes that I've already made. Now let's begin with number 1. You will be asked questions about scatter plots. These are scatter plots where you have a series of dots in hopefully some sort of pattern. If there's no pattern at all, we say there's no correlation. If there's a positive correlation, which we would normally consider to be up and to the right, which is what we have here, then we would call that a positive correlation. Positive means as the weeks increase, the number of items, in this case alibers, increases. While we don't see one here, a negative correlation would be a series of dots that generally trend down and to the right. So a negative correlation would look like this. So positive is up and right, negative is down and right, and no correlation would be, well, a series of dots for sure, but there's no pattern to them whatsoever. Question number 2 is a straightforward solving of an equation. Your steps are the same as they've been all year long. You're going to begin by simplifying both sides using the distributive property and combining like terms. Once you're done with those two steps, the second step is to eliminate the smaller variable from both sides. Now this is assuming that you have a variable on both sides. If you don't, you just move on. But if you do have, which we do, we have a 6b on the left and a negative 4b on the right. The smaller one is negative 4, so we're going to eliminate that from both sides. And now we check for special cases. This does not have a special case, but I'll point them out here. The special case check is if you at this point have an item that equals itself. 5 equals 5, 10 equals 10, A equals A, something like that, then that is infinite solutions. That means the left and the right hand sides are always balanced, and they always will be, so you have an infinite number of solutions. If, however, you have two things that are completely opposite, that doesn't mean 5 and negative 5 necessarily, but two things that are simply not the same, but we're claiming that they are. 5 equals 10 or 9 equals negative 8, something like that. Then you would say there is no solution because those two sides of your equation will never ever balance out no matter what. That is not what we have here. So we're going to now move on to step 3, which is to eliminate the constant. There are two constants here. There is one constant on the side of the variable, right? This is the side that has the variable. And there's a constant number 68. Well, we want to eliminate the constant on the side of the variable, so we want to eliminate that 8. Now the fourth step is to eliminate the coefficient. The coefficient is the number that multiplies the variable. And we are done. That is how you solve any equation in PA Core 8. Now moving on, we get into a series of slope questions. Most of these relate to the same thing. I'm going to be asking you for a slope or an equation or to use an equation. The theme here is that you have one formula for slope that you can memorize. You can also use your notes when you take the assessment. This is the slope equals the second y minus the first y. So in this one it says write the equation of a line. Okay, so we have to come up with an equation. Here's the equation we're going to use. You might remember from class that we had a yellow poster on the wall. This is that yellow poster. And your slope is always the m value. It's the piece that goes in front of the x. It's a coefficient. So we're going to have to calculate slope at some point anyway, so let's go ahead and calculate that first. We take the second y value and we subtract the first y value. On the bottom, we take the second x value, we subtract the first x value. And that is all there is to it. And with that, you've calculated your slope. Now we can partially write an equation. Instead of mx plus b, we can write negative 5x plus b. But now we need to come up with slope intercept, which means we need to fill in two more of these spaces. We have 1, 2, 3 variables. what we'd like to do is fill in 2 of those to figure out the third. And the one we need to figure out, ironically, is b. So we're going to fill in x and y. And you have 2 options here. You can choose 10 and -1 for x and y, or you can choose 14 and -21 for x and y. For me, I like the 10 and the -1 because those numbers are simply smaller. So x is 10, so I have -5 times 10. And on the other side of the equation, y is -1, so I put that in. Now let's solve for b. Now we've run out of space, but we did the job. B is 49. Our y-intercept is 49, and that 49 goes there. So now we have an equation. Y equals the slope that we figured out right off the bat and the y-intercept that we just came up with. And we now have an equation in slope-intercept form. One more time, slope-intercept form was the yellow poster in my classroom. That is exactly the same way you do number 4. So I will not be doing number 4 with you on this video. Let's move down to number 5, which asks about which relationship is a function. Quick heads up here as a reminder, functions have no repeating x values. Or another way to say that is each x has a unique y. Or one other way to say it is that x's can't date 2 or more y's. They have to be, well, they have to be monogamous. X's can only go with one other thing. So look what we have here. Here we have an x which is trying to be with -8, but we have the same x which is trying to be with -4. That is not a function. Letter B, we have 1, 2, 3. Do you see how we have a repeating x? That repeating x is trying to be with 1 and -3 at the same time. That is false. We cannot do that. If we would graph that, that would fail the vertical line test. Letter C, I have -10, 1, -1, and here it is again. -1 and -1. The first one wants to be with 8. The second one wants to be with 10. That would fail the vertical line test. So while we know by process of elimination that it must be D, let's take a look as to Y. And you'll notice that we have 4 unique x's, and therefore there's no way to have repeating x values. Each x has its own y value. X is not trying to date 2 different y's. So we're happy with choice D. Let's move on. Question number 6 is a weird one. Farmer Kent started without any NACSVIPs, whatever that is, on his farm. Every month he added 3 more of them. How many NACSVIPs will he have after 9 months? Well, one more time to the yellow poster. We had a yellow poster that defined our slope-intercept form, and this is one of those forms, meaning we're beginning somewhere, and we're adding or subtracting each day or week, or in this case, month. So here's our pattern. Y equals, now we put the change next to the letter x. That's called our slope. The change is going to be 3 more each month. So 3x. If he would be adding 5 more, we would put 5x. If he would be losing 3 more each month, we would put -3, because negative would indicate a loss. With that in mind, we now want to put the beginning value. This says he began without any NACSVIPs. So I can write +0, but we all know that we don't need that. So we could have a nice simple equation, y equals 3x. And with that in mind, how many NACSVIPs will he have after 9 months? Well, 3 NACSVIPs times 9 months, 3 times 9 will be 27, which is the correct answer for number 6. Number 7 is a rate of change question. I'm not going to do this one for you because it's the same as what we've already done. It's a slope question. The only thing that I will change is note. Since the x value comes first in both of these ordered pairs, and the y value comes second in both of these ordered pairs, I could go ahead and identify that my first column is x, my second column is y, and you know what, while we're here, let's go ahead and do this one. I'm going to go ahead and take my second y and subtract my first y, Look at that minus negative there. And I'm going to take my second x, which is negative 2, and I'm going to subtract my first x, which is negative 3. Subtract negative 3. On the top, I'm going to add the opposite, and I get 0. On the bottom, I'm going to add the opposite and get a 1. Please don't get upset when you see a 0 in the numerator. That simply indicates that slope is 0. Nothing wrong with that at all. If, and we don't have this here, but if we did have a fraction with maybe 1 on the top and 0 in the bottom, this would be no slope, or you might call it undefined. Right? Because we cannot divide by a 0, put a frowny face next to that, so we would call that no slope. But that's not what we have here. We have a slope of 0. Now, one last way to represent slopes. Slope can also be read off of a graph with a phrase rise over run, rises over run. So we're going to identify 2 points on this graph. I'm going to look for points where my pink line touches at a nice, consistent, convenient spot, and I see a number of different options here. You should see some consistency to these points, and now we're going to go ahead and start at one of them. It doesn't matter where we begin. I'm going to begin here, and I'm going to count to another one, usually above it. So I'm going to begin here, and I'm going to end here, and watch what I'm going to do. I'm going to rise 1, 2, 3 spaces. So my rise is up 3, up is positive, down would be negative. And I'm going to, after rising 3, I'm going to run 1 space to the right. Now we know on a number line, to the right is positive and to the left is negative. So that means my run is to the right, so plus 1. So my slope is 3. Very, very simple. Slopes can be fractions, decimals, or whole numbers, even negative whole numbers. And moving on. And the last 2 I'm not going to really do for you. I'm going to remind you only that you can use a couple different strategies to solve systems of equations. For question number 9, at what point do these lines intersect? I see x equals and x equals. I recognize that I don't know how to do a graphing with x equals, so while graphing is sometimes an option, it's not a good option here. Instead, I would take what my x value is. I would substitute that into my x value on top. And I would get 2y plus 14 is negative 2y plus 6. And then I hope you don't get carsick. I'm going to scroll up now. I would say you could go back to question number 2 and look at those rules we used for question number 2. You would use those same exact rules to solve for the value y. Whenever you get your value for y, whatever that value is, 2 or 7 or negative 1/2, whatever that would be, you would then take that value using substitution again, and you would put it into 1, or you'd put it into the other spot for y, and you would then solve for x. All of these systems of equations always get 2 answers. There will be an x value that comes first in your parentheses and a y value that comes second. And not surprisingly, since we studied 3 of them, substitution, graphing, and elimination, number 10 is a good elimination method where I notice its elimination because I see my x's, my y's, my equal signs, and my numbers are all lined up. I happen to have some luck here that I see x's that are the same. So you are allowed to add or subtract. And you might remember that if they are the same, you subtract. If they are opposite, you add. And you are allowed to multiply in order to make them the same or opposite. Now I fear that this video is just as long as they all are, but that is a good and thorough review of everything that will be on the final third of your final